Hi, welcome to what passes for my lab. What you're looking at is the pendulum setup that we use in the labs. Up at top, the whole thing is mounted on a lab stand. The string comes through a piece of tubing here that allows me to move it up and down and shorten the length, and points straight down towards the bob. There's no friction here at this pivot point. However, there's some loss of energy due to flexing the string. It shouldn't be much, but it's one of the possibilities. So back down here. There we go. So this is the bob. It's a mass of a certain size. It should be a point mass. It's not, but it is small. And it is quite massive for its size. So it punches through, or has to move, very little air while it's moving back and forth. So let's hope that air resistance is fairly small. The string is not a massless rod, but the mass of the bob keeps it quite straight. And since it's so thin, it also moves very little air. So it's fairly rigid. I will move it aside like this and let it go. So this is a period. Once whole move. It has to go there, back, and back again. So it's moving in the same direction and at the same position. What drives a pendulum? Gravity. Gravity pulls down on that bob. When I come over here, gravity is pulling down this way, so it wants to go that way. When I pull down here, gravity is pushing this way, and it wants to go that way. That's why it's called a restoring force. The lab document covers all of this, including how we're going to use it. I'm now going to demonstrate how I collected the data. I'll be back in a second. Okay, so here I am with Capstone up and running. The first thing I have to do is set up my hardware. So it can see my 850 interface, not that I showed it to you, but I have to add the photo gate. The photo gate comes with several things. One of them is a pendulum timer. Why a special pendulum timer? Because if you want to measure the period, it has to be back, forth, which means it's going to cross the electric eye several times. And you don't want to count them all, you only want to count them once. And that's what the pendulum timer does. So that's already set up. It knows the size of this ball, the bob. And now I need a graph. Sorry, I'm having some kind of trouble here. Okay, here we go, graph. Set up measurement. I want to know the period. It's going to give it to me over time. That's fine. And we're ready to go. So I have the pendulum set up. The middle of the bob is crossing through the sensor, and I've measured the length of the string using a meter stick. From the tip of the pipe where it comes out to the center of the bob. And now I'm going to hold it at a small angle. Small angles are something you'll figure out in the lab in one of the procedures. And I'm going to let it go. And then I'm going to hit record. And it takes a second here. And you see I'm getting something up here. Let me shrink this a little bit. It looks fairly steady, but of course, to be sure, I want to take the mean, and I don't actually want to take the first couple of parts, so I'm going to do something like this. There, 1.76. I'd like to see a little more information there, so numerical format, and I'm going to go to 3. You know what, let me go back to 4 and say okay. Let's see what that gives us. So there we have 4. So now this has been running for a while, so I'm going to come here and capture it all. And 1.558. Now if you'll notice that if I drag this back, 1.556. It's not changing in the third decimal, it's changing in the last decimal. And that's how much we're losing to loss of energy of this system. Is very, very small. So of course what you want to see is that we'll stop it, that the isochronism. So I'm going to start this over. I'm going to hold this over just a little bit, hit record, and release it. And I'm going to let it run for a little bit. And then I'm going to catch the ball and pull it out a little further and release it again. And I'm going to catch the ball and pull it a little further and release it again. So now I'm pulling it out far enough that it's getting to be hard to call it a small angle. But if you look here, it still looks like it's fairly consistent. The way to tell for sure is to get yourself a measuring device. So I said before, well, 17,571. Do I want that first one? I don't think I want the first one. So I'm going to do this one. Get these. You'll see that this is 1.7571. This one is 7591. That's 2 milliseconds faster, longer. And this one, let me get another data point in there, 7650. So there is a small change, and that may be because I've extended the angle to where it's no longer can be considered a small angle. You'll learn what that is in the report. And that's it. This is just a demonstration audio. All of the information you need to complete all of the procedures is in the file. Most of them are just introductory stuff. Help you learn what G is, what a small angle is, things like that. The final 2 procedures, one, I will actually take a run of these and I will find you 10 data points for 10 different lengths and compare the period to it. You'll have to plot it and use it as a gravimeter to calculate G. The final procedure is the big one for you. You're going to actually have to build your own pendulum. So we don't expect you to have it set up like this, but you can look around and you can find. A pendulum is just a mass on a string. You're going to look for a way to minimize the uncertainty in your measurement. And we're going to do it as a type A analysis. So we're going to collect values for G for all of the students, and then we're going to compile them and see what we can come up with. And that's it. That's lab 2.